This is example 7.7 from Discovering Design with Chemistry. The problem says PCl5 is used in the manufacture of some pesticides. It can be produced as follows. And then we have a chemical formula equation going on here. If a chemist needs 975 grams of PCl5, how many grams of Cl2 does she need? All right, so we know how many grams we want of this. We want 975 grams of PCl5. But what we don't know is how many grams we need of the Cl2. This equation does not give us, or this formula does not give us how many grams we're using of each. What it gives us is how many moles we're using of each. So like 1 mole of P4 plus 10 moles of Cl2 gives us 4 moles of PCl5. So what we need to do is we need to convert this into moles of PCl4. And then we can go from there. So let's start by doing that first. So to get a conversion relationship, we have to remember we have to add 1 times the number right here plus 5 times the number right here. And when we do that, that will give us how many grams is in 1 mole of PCl5. And then we can figure out how many moles we have. So first we're going to figure out, so 30.97 plus 5 times 35.45. And remember, this is like 35.45 being added 5 times. So the 5 does not affect our significant digits. So 30.97 plus 5 times 35.45. So we're just adding. So we're still going to keep it at the hundredths place, because when we add, we keep the place value the same. Oh, I made my number go away. 208.22. 208.22. That's how many grams, I'm going to slide this over, is in 1 mole of PCl5. I just realized I wrote the wrong number right here. It should be a 5. All right, and because we're going to work with the Cl2 later, let's go ahead and make a conversion relationship for that. So 1 mole of Cl2 is the same as 2 times 35.45 grams of Cl2. And again, when we multiply 35.45 times 2, we're actually just adding it to itself twice. We need to keep 70.90 grams is how much that is. All right, so we will use that in a minute. So now that we know that this many grams equals 1 mole of this, we can take the number of grams that we have, which is 975 grams of our PCl5, and we can convert it into moles, which is what we need to work with the chemical equation up there. So let's do grams of PCl5, because that's what we want to get rid of, and we want to turn it into moles of PCl5. And we're going to use this same relationship right here that we've already created, or not created, but like that we've already calculated. So 1 mole of that is 208.22. In this we have 3 significant digits in one number and 5 in the other, so our answer is going to have 3 significant figures. And it's going to give us the answer to tell us how many moles of PCl5 that we have. So we have 975 divided by 208.22. We can only keep 3 digits. 4.68, the 2 does not make it round up, so we're going to just have 4.68. So that's how many moles that we have of this one right here, which is kind of cool because it's actually close to the number that it says. So we have a little more than we would, kind of the ratio that we have going on. All right. To get to the next step, we want to know if we want to make, we know we want to make 975 grams. So we instead can say we want to make 4.68 moles of PCl5. Just like in the two previous examples, or maybe three of them that we did, we're going to figure out how many moles of Cl2 we need to make. And then we'll put that in grams because that's what the problem actually asks us for. So let's change color real briefly. So for every 4 moles of PCl5 that we want to make, we need to start with 10 moles of Cl2. So we have this many moles that we want to make, and so we're going to use this conversion relationship to figure out how many moles of Cl2 that we need. All right, so let's push this to the side a little bit more and keep going. So we have 4.68 moles. I'm not going to keep writing. Well, yeah, I need to keep writing it or we'll forget what we're doing. And what I want this in moles. But I want to get rid of the PCl5 and turn it into Cl2. So let's use our conversion relationship that's up here. So the 4 goes on the bottom and the 10 goes on the top. And then I can just pull out the calculator. Remember, the 10 and the 4 are just a conversion factor. They're exact. We don't have to worry about them as far as our significant figures go. And these will cancel, and that will leave us with how many moles of Cl2 that we need. So 4.68 times 10 divided by 4. So we have 11.7, and that's perfect. It already has 3 significant digits, so 11.7. So that's how many moles of Cl2 we need to produce the amount that she wants in moles of the PCl5. But they didn't ask us how many moles of Cl2 she needs. They asked us how many grams of Cl2 she needs. So now we need to take this number that we just got, and we need to convert it to being grams of Cl2. This is where this conversion up here makes sense, or where it's needed. All right, so let's do another color. All right, so we need to use 11.7 moles of Cl2, and we're going to convert that into grams of Cl2. You know what? I don't actually need this to be quite that big, and then I'll have room for my answer. All right, so we want grams of Cl2, and we want to get rid of the moles of Cl2. So we're going to use this to convert it. So for every 1 mole of Cl2, we have 70.90 grams of Cl2. Our moles will cancel, and it will leave us with just how many grams of Cl2 that we need. So we just need to multiply those two numbers. In this sense, both this number and this number both matter for significant figures. And since we're multiplying, we care about how many. And so our limiting answer, or our answer, is limited to 3 significant figures. I should have just left that one up. All right, 11.7 times 70.90. So we only get 3 significant figures. That means we're going to have to round this to the ones place. So 830. 830. So she needs to use 830 grams. So this is our final answer. The other things I've boxed were kind of like steps along the way. So let's kind of go back and review what we did. They told us, let's get rid of the periodic table. We don't need that for the review. All right, so if you understood what I did, you can stop the video now. If you didn't, if you followed it, but you're not sure if you could repeat it, let's review real quick. So we wanted to figure out how many grams of one of the reactants we needed, and we were told how many grams of the product that we were wanting to have. The problem is the little chemical, the chemical formula that they gave us, the equation, doesn't give us grams of each item, it gives us moles of each item. And so we have to start with the grams that they gave us, convert that to moles, work in moles for a while, find the moles of the last thing, and then convert that back to grams. So that's what we did. Okay, fine, I'll choose a highlighter. So we started with the 975 that they gave us, and we converted that into moles. Same substance, still PCl5, but moles. The way we did that was by figuring out what the conversion relationship was. This is our conversion relationship. We found that by using the periodic table. We took the P, its atomic mass unit, its atomic mass. We took 5 atoms of the chlorine using its atomic mass, and we put those together to find what 1 mole of that particular molecule would, or that particular substance for the PCl5, what 1 mole would be in grams. And then that gave us a conversion relationship that we were able to use right here to convert from the grams that we had to the moles that we needed. Let me get rid of some of those extra highlights. Okay, and then we use that number to figure out if we have this many moles that we're wanting, because that's what this number is. We've just converted from grams that we want to moles that we want. We changed what our unit was. Now that we're in moles, we could work within the problem that they gave us here. We use that to convert from moles of the PCl5 to moles of the Cl2. To do that, we used another conversion relationship. This one's much easier to figure out. We don't have to use the periodic table. We just use the formula that they gave us. Once we converted that over and realized how many moles we needed, and you can kind of see how it's close. For 4 moles of this, it makes 7 moles of that. This is a little over 4. Did I say 7? I have no idea why I said 7. For 4 moles of this, we get 10 moles of that. This is a little over 4. This is a little over 10. So it logically makes sense. You can see where it went. Once we had the right number of moles of Cl2 that we wanted, we just had to put that in grams because the answer asked us for Cl2 in grams, not in moles. Again, we started with the moles that we figured out. We used a conversion relationship and we changed it into grams. To find the conversion relationship, we used the periodic table. We know how much chlorine's atomic mass is, and we were able to multiply that by 2 because chlorine is Cl2 in this problem. And we found that there were 70.90 grams for 1 mole of Cl2. And so once we had that conversion relationship, we could convert it back to the grams that we needed. In your book, right after example 7.7 is a little picture that shows initial Massburg, and it goes down a road past West Mulville, East Mulville, and then to final Massburg. And it's just a little sort of a roadmap to kind of help understand what we're doing in these. And what we're usually doing is a lot of times we are given mass and we want mass, but because the equation doesn't work in mass, it works in moles, we have to convert to moles, deal with the equation, get the moles we want, and then convert that back to mass. And so if you think of that like a roadmap, that's what we just did. Sometimes they give you moles, which means you get to just start in West Mulville and you can skip converting anything and just go straight to working with the equation. And then when you're done, convert it to grams. Other times they give you grams, you have to convert to moles, but then they ask for the answer in moles. So once you get your answer, like we did right here, if they had asked for moles, we wouldn't have had to convert back to grams. If you don't understand the picture, I might make a video about that, or I might explain it to you in person if you're in my class so that we can understand what that's about. The next problem is going to kind of do the same concept again, where we have to do some conversions between moles and grams and work with a chemical equation.